So this is the continuation of the video of de novo purine and pyrimidine synthesis, and in this particular video I'll be talking about pyrimidine synthesis specifically, starting off how it comes from PRPP, how PRPP is a general substrate and how we can make both purine and pyrimidine from it. So let's get started. So I just moved our PRPP a little bit to our right, and PRPP is coming from ribose 5-phosphate. We already talked about that. So this PRPP, what this PRPP is doing, this PRPP is making our UMP, but this PRPP is using orotic acid, PRPP, and carbon dioxide to make UMP. So orotic acid is making UMP using PRPP and carbon dioxide in this step. But where are we getting our orotic acid? That is a bigger question. Orotic acid comes from a substance called carbamyl phosphate in addition with aspartate. So, and how are we getting carbamyl phosphate? So let's start from the beginning. What we have here is, at the very beginning, because we're talking about de novo, we have carbon dioxide, glutamine, and ATP. All these combines to make carbamyl phosphate. And this reaction, this reaction is stimulated by an enzyme called CPS2, or carbamyl phosphate synthetase 2. So where do we use CPS1? Do you remember? We use CPS1 in synthesis in our urea cycle when we make carbamyl phosphate from using bicarb, using ATP and ammonia. We use CPS1 to make our carbamyl phosphate there as well, right? So this carbamyl phosphate can also shuttle from the urea cycle. But in this de novo pyrimidine synthesis, we're making it from three different substrates here. Carbon dioxide, glutamine, and ATP is making our carbamyl phosphate. Now our carbamyl phosphate is then giving rise to our orotic acid, and this step needs an amino acid, okay? And this amino acid is going to be our aspartate. Remember, this step needed aspartate as well. So just giving you a little reminder. So from carbamyl phosphate to orotic acid, we are using aspartate. And then the story continues. Carbamyl phosphate making orotic acid. Orotic acid is using PRPP and carbon dioxide to make UMP. From UMP, we're making UDP. From UDP, we make DUDP and CTP, just like here. From UDP to DUDP, this step is stimulated by ribonucleotide reductase. This step is very important to remember. Our ribonucleotide reductase is inhibited by one cancer drug, hydroxyurea. So when we're talking about remembering different steps, the steps that is inhibited by drugs, very important to remember, that is clinically significant. Regulatory steps, so in our pyrimidine synthesis, the regulatory step is CPS2, very important to remember. So any enzyme that I'm mentioning in this particular video, very important to remember, because we are definitely skipping some for sure. So anyways, let's continue. From our DUDP, the next thing is going to be DUMP. From DUMP, we get DTMP. So from DUMP to DTMP, this step needs folate. Now, how exactly are we using this folate here? We have something called N5, N10 methylene tetrahydrofolate. We're using this in this step, and this tetrahydrofolate is being converted to dihydrofolate, okay? And we're using the folate we're using to make DTMP from DUMP. And this step is stimulated by the enzyme thymidylate synthase. Okay? Now, before I talk about some thymidylate synthase, I want to finish our story on our folate. Now, we have tetrahydrofolate being converted to dihydrofolate. Dihydrofolate is again converted back to tetrahydrofolate, and tetrahydrofolate converts to N5N10 methylene tetrahydrofolate to get used in our pyrimidine synthesis. Now, the step from dihydrofolate to tetrahydrofolate, we're using the enzyme dihydrofolate reductase. Dihydrofolate reductase. And this step is inhibited by a bunch of drugs. Methotrexate, our anti-cancer drug. This is also inhibited by TMP, trimethoprim. Okay, TMP-SMX, the trimethoprim. Another drug inhibits this step, and that is pyrimethamine. Okay, pyrimethamine is an anti-protozoal drug. All these drugs are going to be inhibiting our dihydrofolate reductase. Okay, now let's talk about this step. I know this, from here to here, there's a lot of information, but every one of them is important. From DUMP to DTMP, we use the enzyme thymidylate synthase, and this thymidylate synthase is inhibited by 5-FU. I hate this drug. I hate this pathway. So 5-fluorouracil inhibits thymidylate synthase. Some additional information if you wanted to go the extra step. Tetrahydrofolate to N5N10 methylene tetrahydrofolate. This step is using the enzyme aspartate transcarbamylase. Okay, if you wanted to remember that, not very high yield. Another thing I want to mention is that you see how this making UDP is so important to finish our pyrimidine synthesis. If you had problem in any of these steps or any of these enzymes are missing, then you're not going to have UDP. If for any reason a child has deficiency of any enzymes before UDP, then you can replace that. You can skip all this using uridine. Uridine, you can bypass all these steps and make UDP directly, and you only have to worry about the following to make our pyrimidine synthesis.